Did you ever ponder how the infinite expanse of space could be instrumental in our understanding of climate change? It's not something we often think about, but the cosmos and our climate are more interconnected than you might believe. Today, we're going to delve into this fascinating relationship. Space is not just about galaxies far, far away, or the quest for extraterrestrial life. It also holds the key to comprehending the complexities of our own planet's climate. From thousands of miles above the Earth's surface, space-based technologies and observations are revolutionizing the way we monitor and understand climate change. Satellites capture images, provide data, and even help create predictive models of climate patterns. Meanwhile, atmospheric studies from space give us insights into the intricate dynamics of our climate. So, buckle up for an astronomical adventure as we explore the cosmos and its crucial role in our climate research. So let's venture into the cosmos and uncover the top 10 ways space impacts climate change research. Taking the number 10 spot, we have satellites, our eyes in the sky. Satellites zoom around our planet, tirelessly gathering data and beaming it back to us. They're like diligent little detectives, ceaselessly monitoring Earth's atmosphere, oceans, and land surfaces. By capturing images and collecting other types of data, satellites offer us a comprehensive snapshot of our planet's current state, from the swirling vortex of a hurricane to the steady retreat of a glacier. Now you might be wondering, how exactly do satellites help us understand climate change? Well, they're instrumental in tracking a host of key indicators. For instance, they monitor weather patterns, which help us understand and predict climate phenomena like El Niño and La Niña. They keep an eye on the sea levels, documenting the steady rise as our planet warms. They watch the polar ice caps, recording the ebb and flow of ice during different seasons and over the years. And it's not just about capturing images. Satellites are equipped with a range of instruments that measure different aspects of Earth's systems. They can measure the temperature of the sea surface, the density of the forest cover, the concentration of greenhouse gases in the atmosphere, and so much more. In fact, some of the most compelling evidence of climate change comes from decades of satellite data. But satellites aren't just passive observers. They're also active participants in climate research. They help calibrate ground-based observations, validate climate models, and even provide data for new hypotheses and theories. It's fair to say that without satellites, our understanding of climate change would be far less comprehensive and far less accurate. So, as we continue to grapple with the challenges of a changing climate, let's take a moment to appreciate these silent sentinels in the sky. They're our eyes and ears, helping us see the big picture, hear the subtle changes, and understand the complex systems that make up our planet. With satellites, we have a bird's-eye view of our planet and its changing climate. At number 9, we have climate models, our crystal ball, for predicting the future of our climate. Now, you might be wondering, how exactly does space technology contribute to these climate models? Well, let me tell you, it's a fascinating process. Space-based observations provide a wealth of data that we simply can't get from the ground. Satellites orbiting our planet capture images and data about the Earth's surface, atmosphere, and oceans. This information is then fed into complex computer models which simulate the Earth's climate system. These models are like giant jigsaw puzzles, each piece representing a different component of the climate system, from temperature and rainfall to wind patterns and ocean currents. Even factors like vegetation cover and human activities are included. And here's the best part. Once all the pieces are put together, these models can simulate how the climate might change over time. But these models aren't just about predicting doom and gloom. They also allow scientists to test different scenarios, to see how changes in greenhouse gas emissions, for instance, might impact the climate. This means we can use these models to help decide the best course of action in mitigating climate change. Now, it's important to remember that these models aren't perfect. They're based on our current understanding of the climate system, which is constantly evolving. And the future is, of course, inherently uncertain. But these models are our best tool for predicting the future of our climate and guiding our actions today. And let's not forget, none of this would be possible without the help of space technology. From the satellites collecting data to the supercomputers crunching the numbers, space technology is integral to our understanding of climate change. So, next time you hear about a climate prediction, remember the role of space technology in making that prediction possible. And remember too, the power that these models give us to shape our future and protect our planet. With climate models, we can look into the future of our planet's climate. Number 8 on our list is atmospheric studies, our climate detective. Picture this. You're a detective, and your case is the Earth's atmosphere. This isn't your run-of-the-mill assignment. It's a case that's been in the works for billions of years and is changing faster than ever before. Our tools for this investigation are space-based instruments. These high-tech gadgets measure the composition of Earth's atmosphere, providing us with crucial clues about its past, present, and future. These instruments are like microscopes peering into the vast expanse of the atmosphere. They measure everything from trace gases and aerosols to temperature and humidity, all of which play key roles in our climate system. One of the most critical aspects they measure is greenhouse gases, such as carbon dioxide and methane. These gases trap heat from the sun, warming our planet, a process known as the greenhouse effect. However, an excess of these gases can lead to an overheated Earth, resulting in climate change. By monitoring the levels of these gases in the atmosphere, we can better understand how human activities are contributing to their increase and the consequent warming of our planet. This information is vital to climate change research, informing policies and strategies to mitigate the effects of global warming. But it's not just about the present. These space-based instruments also offer a glimpse into the past. By analyzing ice cores, researchers can study the atmospheric composition dating back hundreds of thousands of years. This provides valuable insights into how the atmosphere has changed over time and how it might continue to change in the future. On the flip side, these studies also allow us to look forward, creating predictive models of how our atmosphere might evolve under different scenarios. These models help guide our actions today to ensure a sustainable future for our planet. Atmospheric studies are like a time machine, allowing us to delve into the past, understand the present, and predict the future. They are an essential tool in our quest to comprehend and combat climate change. With atmospheric studies, we can unravel the mysteries of our ever-changing climate. Taking the 7th spot, we have solar radiation, the heat source of our planet. Imagine a world where your hands can touch the sun's rays, dissecting them, analyzing them, understanding their impact on our climate. Thanks to space-based observations, this is no longer a realm of fantasy, but an achievable reality. Solar radiation, the radiant energy emitted by the sun, is the primary source of Earth's heat. This sunshine, as we fondly call it, does more than just provide us with a sunny day at the beach. It quite literally powers life on Earth, driving the processes that make our planet habitable. But what happens when there's a change in this radiation? What if the sun starts to sizzle a little more, or perhaps cools off a bit? This is where space-based observations come into play, allowing scientists to track these changes and understand their impact on our climate. Satellites orbiting Earth with their advanced sensors continually monitor the amount of solar radiation reaching our planet. These eyes in the sky provide invaluable data, helping us understand the sun's energy output and how it varies over time. Now you might be wondering, how does this relate to climate change? Well, changes in solar radiation can affect global warming. If there's an increase in the sun's energy output, it could lead to a warmer Earth. Conversely, a decrease could cool things down a bit. But it's not that simple. Our climate is a complex system, influenced by numerous factors, not just solar radiation. However, understanding the role of solar radiation in this jigsaw puzzle of climate change is crucial. It helps us decipher how much of the current global warming is due to natural solar variability and how much is due to human activities. So, the next time you bask in the sun's warmth, remember, there's more to those rays than meets the eye. They're not just bringing warmth to your day, but also playing a significant role in shaping our planet's climate. With an understanding of solar radiation, we can uncover how the sun influences our climate. Coming in at number 6 are space-based research platforms, our climate lab in the cosmos. These platforms, such as the International Space Station, are like floating laboratories, offering an unparalleled vantage point to study our planet and its climate. From their lofty perch, scientists are conducting unique climate experiments and observations that would be impossible to carry out on the ground. Consider the International Space Station, an orbiting powerhouse of scientific discovery. Here, astronauts are not just floating around, they are working tirelessly, conducting a wide range of experiments that help us understand the intricacies of Earth's climate. For instance, they monitor the ozone layer, track hurricanes, and study how the Earth's atmosphere interacts with the sun. But why is this important? Well, these experiments offer invaluable data that help us to better understand and predict changes in our climate. They provide a unique perspective on global weather patterns, ocean currents, and the distribution of plants and animals. In addition to the International Space Station, there are dozens of other satellites and research platforms in space that contribute to climate change research. These platforms carry instruments that can measure temperature, humidity, and greenhouse gases with astonishing precision. For example, the Orbiting Carbon Observatory, a NASA satellite, measures carbon dioxide in the Earth's atmosphere. This data is invaluable for tracking the sources and sinks of this potent greenhouse gas. Other platforms, like the European Space Agency's Cryosat, are focused on the polar regions, providing crucial data on the state of our planet's ice caps. Space-based research platforms are not just about data gathering, they are also about collaboration. Scientists from around the world work together, sharing data and insights to gain a deeper understanding of our planet's climate. This is the power of space-based research platforms. They allow us to look at our planet from a distance, to see the big picture, to understand the complex interactions that shape our climate. With space-based research platforms, we can study climate change from a new perspective. And now for the final countdown. We've traveled through the cosmos to understand the intricate dance between space and climate change. As we hurtle towards the climax, let's take a moment to reflect on the journey so far. We launched our exploration with the Cosmic Climate Connection, understanding how space and Earth's climate are inextricably linked. Then, we zoomed in with the Eye in the Sky, our satellites, which tirelessly orbit our planet, capturing invaluable data about our changing climate. We then dove into the world of climate models, our crystal balls that predict the future of our planet's climate. These models, enhanced by space-based observations, allow us to prepare for and mitigate the effects of climate change. Next, we donned our detective hats to explore atmospheric studies. Like climate detectives, scientists use space-based technologies to study our atmosphere, uncovering clues about how it's changing and what that means for life on Earth. We then turned our gaze to the Sun, our planet's heat source. We discussed solar radiation and how its fluctuations, observed from space, play a vital role in our climate system. Finally, we ventured into the high-tech world of space-based research platforms, our climate labs. These platforms offer a unique vantage point to study our world, providing crucial insights into the complex mechanisms of climate change. Phew, that's quite a journey we've been on, and we're not done yet. We're standing at the precipice of the top 5 ways space impacts climate change research. Can you feel the anticipation building, the cosmic tension? The excitement is palpable. We're about to delve into the most groundbreaking, influential ways that our exploration of the cosmos is helping us understand, combat, and adapt to climate change. The top 5 are not just steps in research, they're giant leaps for mankind. Stay tuned as we unveil the top 5 ways space impacts climate change research. Welcome back to the final leg of our cosmic journey. We've been through a fascinating exploration of how space, the final frontier, impacts climate change research. Now it's time to unveil the top 5 ways. In 5th place, we have the study of solar radiation. The sun is our primary source of heat after all, and understanding how it affects our planet is crucial. Space-based observations provide us with unparalleled data on solar radiation, helping us to better comprehend its effects on Earth's climate. Coming in at number 4 are the space-based research platforms. These platforms, floating in the vast expanse of space, serve as high-tech laboratories. They provide us with a unique vantage point to conduct experiments and gather data that would be impossible to collect from Earth. Bronze goes to atmospheric studies. The Earth's atmosphere is a complex system, and studying it from space gives us a comprehensive view of its workings. We can observe atmospheric patterns, track greenhouse gases, and monitor the ozone layer, all of which contribute to our understanding of climate change. The runner-up is the use of climate models. These models, powered by data collected from space, allow us to predict future climate scenarios. They are our crystal ball, enabling us to foresee the potential impacts of climate change and prepare for them. And finally, claiming the top spot are satellites. These eyes in the sky provide us with a continuous stream of data on Earth's climate. They monitor everything from sea level rise to temperature changes, helping us to understand the magnitude and pace of climate change. So there you have it, the top 5 ways space impacts climate change research. From the heat source of solar radiation to the observational power of satellites, from the experimental potential of space-based research platforms to the predictive capabilities of climate models and the comprehensive view offered by atmospheric studies, space indeed plays a crucial role in our understanding of climate change. As our journey comes to an end, let's summarize what we've learned. From the cosmic climate connection that binds our existence to the universe, to the eye in the sky, satellites, providing us with invaluable data on Earth's climate. We've delved into the crystal ball of climate models, predicting our planet's future with increasing accuracy, and played detective with atmospheric studies, tracing the clues of climate change. We've felt the heat with solar radiation, the power source driving our climate, and explored the innovative space-based research platforms that serve as our climate labs. As we counted down the significant ways space impacts climate change research, we unveiled the top 5, each one more crucial than the last. As we continue to explore the cosmos, we find that it holds the keys to understanding our changing climate. So, the next time you gaze at the night sky, remember, space isn't just about stars and galaxies. It's also about our home, the Earth. Before we wrap up, it's time for us to take a step forward. If this cosmic journey has sparked a new understanding in you, then it's time to act upon it. Climate change is not just a problem for scientists to solve. Each one of us, as inhabitants of this beautiful planet, has a role to play. The knowledge we've gained from our cosmic explorations isn't just for textbooks, it's a call to action. Each fact about our climate, each prediction from our models, is a piece of a larger puzzle. And now that we have the pieces, it's up to us to put them together to create a sustainable future. So if you learned something new from this video, then please give it a like and share your thoughts in the comments. Your engagement helps us spread this crucial message further. Don't forget to subscribe and press the bell icon for more content like this. And share this journey with your friends and family. The more people who understand the cosmic climate connection, the better our chances of preserving our planet for future generations. Thank you for watching, and remember, every time you look up at the night sky, you're not just seeing stars, you're seeing a reflection of our home. Let's do our part to keep it beautiful.